Welcome to my Introduction to Networking course, also known as ITN. This is the version 7 material preparing learners for the Cisco CCNA 200-301. Cisco curriculum, everything is owned and copyrighted by them. So moving on, let's talk about fiber optic. Fiber optic is not as common as unshielded twisted pair. Fiber optic is using a light source to send data. While fiber optic is definitely more suitable in certain networking situations, it is a little more expensive. The light could be either a laser or LED, and the core portion of the fiber optic cable could be glass or plastic polymer. How fiber optic works is it will send a light using wavelength, and the cable itself will guide the light between one end and the other end. This actually allows for the minimal signal loss while sending light signals throughout the cable. So it's important to point out that fiber optic is a pair of cables, one for sending, one for receiving. Fiber optic comes in two other flavors, single mode and multi-mode. You'll notice that single mode will have typically a smaller core, and it will use a laser to shoot the wavelength through the cable. Single mode is made for longer distances, while multi-mode allows for multiple signals to be sent through different angles. It will use a much larger core, and it will use a LED instead of the laser. The LED allows for the transmission of light at different angles. And typically multi-mode does still go longer distance, but it doesn't go as long as single mode. Again, light over X amount of length will eventually degrade, but we're talking thousands of meters as opposed to feet. Fiber optic comes in a few different flavors, like fiber to home, fiber to the building, things of that nature. Well, we also have transatlantic or transoceanic connections. Those are fiber connections that go underneath the ocean to other continents. If we are talking large fiber connections between large cities, those are going to be long-haul networks. So connecting Vegas to LA, there's a long-haul cable that connects the two. Connecting Seattle to LA, again, long-haul cables. So common fiber connections are going to be a few different types of different connectors. We'll have a straight tip connector, we'll have a SC connector, we'll have an LC connector. That LC, you may only see one portion of it, but in reality, they come in two. They do not allow for single or half duplex. They only do duplex, one for sending, one for receiving. The nice thing with fiber is one end can have one connector, the other end could have a different connector. They can vary. So you can have an SC to SC or an ST to LC. If one side has one type of connector for fiber and the other end has a different connection for fiber, it works. Where with copper, you only have very specific types of heads, and that is it. Comparison, distance, if we're talking copper-based cables, lower distances. Copper is susceptible to EMI, RFI, other electrical issues, though copper cable is typically cheaper to install. Bandwidth is always an issue because newer copper-based cables show equal length when it comes to the actual speed of the cable. So got to keep that in mind. Right now, copper-based cables are tapping out about 10 gig, though newer category cables can actually reach the same 100 gig that fiber can. But fiber has the distance, meaning fiber is way further than our copper can. Moving on is our wireless networks, our wireless media. Again, our wireless will carry an electromagnetic signal representing binary through the airwaves, provides greater mobility. Limitations are going to be how far the wireless can go, coverage area. If there's anything interfering with that, that's interference. Protection in form of security, and shared media. Wireless LANs operate in a half duplex, meaning they can only send or receive at a time. Also, with wireless, the more users using it, the slower it becomes. Common types of wireless are the traditional wireless, IEEE 802.11. That's what you'd see in a home. Bluetooth is 802.215. Again, that's going to be Bluetooth like your phone and your car, things of that nature. WiMAX is going to be a lower speed but greater distance wireless using the old TV. We have Zigbee, which is some form of IoT communication standard, though Zigbee is not the only one. So we're talking standards for wireless. We're talking things like antenna design, how the wireless reception and decoding requirements are going to be, the frequency, the power of the frequency, how much power can we put on the wireless device. That also equates to speed and distance. Data radio signal methods are another big one. All of these are outlined in IEEE standards for wireless. So with 802.11 being traditional wireless, we need to dig into that a little deeper. Typical in a wireless, like a home wireless setting, we have a wireless device, your computer, your phone, your laptop, and that's going to have a wireless NIC. We have the device that will then control the wireless signal to put it on a wired network. That's typically some form of wireless access point, and that allows the wireless connections to be copied to or to be transmitted over a wired network. In a home setting, that may be a wireless router, because that's going to be a router and wireless access point built into one. If we're talking enterprise, we may have dedicated access points, sometimes called a WAP, wireless access point, or an AP access point, that allows for wireless to be distributed throughout a building, and then each of the access points would be hardwired back to the wired network. We actually have a packet tracer where you're doing this. And that is it for this chapter. If you have any questions or concerns, please reach out. So what did we learn just overall? We learned about different types of physical layers, STP, UTP, coax. We learned about some of the key standard protocols like IATIA, IEEE, IANA. We talked about the functionality of layer 1. We talked about multi-mode fiber. We talked about single mode, multi-mode, single mode being further, multi-mode being LED and quite can't go as far. We talked about wireless. We talked about IEEE 802.11, Wi-Fi. We talked about Bluetooth, WiMAX, and we talked about basically how a wireless LAN operates using an access point and wireless NICs. Lastly, we have another packet tracer about connecting devices and troubleshooting. And that is this chapter in a nutshell. If you have any questions or concerns, please reach out.